Episode 5, Insecure Design, Flaws Before Code. What if your application is perfectly coded, but fundamentally insecure by design? You followed all the best practices, sanitized inputs, and ran your tests, but attackers still break in. Why? Because the problem isn't in your code, it's in your design. Welcome to Episode 5 of our OWASP Top 10 Breakdown. Today's focus: Insecure Design, a newer but critical category that focuses on flawed decisions made before a single line of code is written. 1. What is insecure design? Insecure design is about security weaknesses that come from flawed architecture, workflows, or logic, not code mistakes. Think of it like this. Your app is a house. You used the best bricks, but forgot to put locks on the doors. The weakness is in the blueprint, not the build. 2. Why did OWASP add this? Insecure design was added to the OWASP Top 10 in 2021 to recognize a deeper problem. Many security issues start at the requirements or architecture phase, long before coding begins. OWASP defines insecure design as missing or ineffective control design. It's about failing to anticipate how systems can be abused. It's different from implementation bugs. This is about what you build, not just how you build it. Examples of insecure design. Here are common examples of insecure design in real applications. 1. Lack of rate limiting, allowing unlimited login attempts, leading to brute force or credential stuffing attacks. 2. Flawed access control. Logic users can modify their own roles by changing a user ID in the URL. 3. Business logic abuse. A shopping cart that lets attackers apply the same discount code multiple times, or bypass payment entirely. 4th, insecure workflow design, allowing password changes without requiring the current password or a valid session. 5. Overly permissive defaults APIs that expose internal data or functions simply because it's easier for dev testing. 6. Missing threat modeling building, a feature without considering how it could be misused, like file uploads without virus scanning. 4. Real-world incidents. Real-world insecure design flaws have led to serious breaches. Uber, 2016. Poor access control logic let attackers gain access to AWS credentials, hard-coded into private GitHub repos. The breach affected 57 million users and drivers. Robinhood, 2021. A support system was accessed using social engineering and overly broad internal permissions, resulting in data leaks affecting millions. E-commerce sites. Many have lost revenue due to design flaws in coupon or referral systems that let users game the system. Sources: FTC reports, SEC filings, HackerOne public programs. 5. How is this different from other vulnerabilities? Unlike injection or authentication bugs, insecure design is upstream. It can't be fixed with a patch. It has to be addressed with better planning. For example, a SQL injection is a bug. Fix the query. But designing a login system without multi-factor authentication, that's insecure by design. 6. How to prevent insecure design. Preventing insecure design means making security part of your software development lifecycle, SDLC. Here's how. 1. Use threat modeling. Identify how attackers could misuse or abuse features before building them. Use tools like Microsoft Threat Modeling Tool or OWASP Threat Dragon. 2. Define security requirements. Early set clear security goals at the planning stage. Rate limiting, role boundaries, session timeouts, etc. 3. Design for fail-safe defaults. Deny access by default. Only allow what's explicitly permitted. Create abuse cases, not just use cases. For every feature, ask, how could this be abused? 5. Perform architecture risk analysis, ARA, especially for critical components like authentication, file storage, or API gateways. 6. Use reference architectures. Don't reinvent security. Follow battle-tested designs from OWASP, NIST, and industry frameworks. 7. Conduct manual reviews and security design workshops. Get security experts involved before finalizing your architecture. 7. A quick case study, flawed checkout logic. Imagine a checkout system where a user can apply a promo code multiple times by refreshing the page. It's not a coding bug, it's a logic flaw. No one asked what happens if this step is repeated, or can this be manipulated? This kind of design oversight leads to revenue loss, not just data loss. Insecure design is hard to detect after development, but easy to prevent with the right mindset. Security isn't just a checklist, it's a design principle. Start early, think like an attacker, and build with abuse in mind. In the next episode, we'll tackle one of the most exploited vulnerabilities of all time: security misconfiguration. Hit subscribe to stay ahead of the curve and keep building securely. Sources and verification: OWASP Top 10, A04, 2021. Insecure design, https owasp.org, Top 10, A04, 2021. Insecure design, OWASP Secure Design Principles, https owasp.org, www.project Secure Design Principles. OWASP Threat Modeling Cheat Sheet, https cheatsheet.owasp.org/cheat sheet/threat-modeling-cheat-sheet.html. Microsoft Threat Modeling Tool, https learn.microsoft.com/n-us/security/engineering/threat modeling tool. Uber Breach Report, FTC, https www.ftc.gov. News events, press releases 2018 where Uber agrees, expanded settlement FTC cover-up data breach. Robinhood 2021 breach, https blog.robinhood.com, news 2021 11/8, important security update.